Okay, 4-1, day 2. So this whole inverse variation thing is now all of a sudden going to look different, feel different. Go back to graphing. So we're going to start with some basic knowledge you should just know so you can understand part of my explanation. Now, I've got more to say about that. But what's 10 divided by 2? You are correct. That's 5. How come? Because 2 times 5 is 10. Now what's 10 over 0? Some of you want to say 0. Well, that can't be true because 0 times 0 does not equal 10. So you know what? This is no solution or undefined. This is part of your domain or just something that can't happen. You can never, ever, ever have a 0 in your denominator. It's mathematically impossible. Now I'll throw this in for free. 0 over 10, yeah, that can be 0, because 10 times 0 is 0. So the only thing that you have to really be on the lookout for over your whole mathematical career, just can't ever have a 0 in the denominator. Now, here comes something crazy. If you can't ever have 0 in your denominator, the only thing you can have is any number, positive or negative. Well, 10 divided by anything other than 0, because we know that's impossible, that also will never equal 0, because it's going to be 10 over something. Keep that in mind as we move forward into this discussion. So here we have this crazy looking equation. Now I'm going to give you guys a little nudge, okay? If I looked at this, I go, you know what? I know that's a line. Y equals mx plus b. If I look at this, I go, aha, parabola, we're getting good. Cubic function kind of looks like that. Now, you guys haven't dealt with many of these. It's called a reciprocal function. So, you'll get used to this, but all of these, when you have your x in your denominator, are going to be some version of this. How do you know that? Well, you don't. Now you can type that into your Desmos, but this section, again, is expecting you to be able to graph this stuff by hand. I know that's frustrating as a math student, but we want you to understand where it comes from, work through the pain of actually like plotting some points. After you kind of go, oh, I kind of get it, then we'll, no problem. Use, Desmos all you want. Anyways, here's the point. The domain of this, remember domain is x. We know from this slash this, we know that x can't equal 0. Range, what is range? Range is about your y. Well, if that can't equal 0, 1 over any number is going to give me something. So we know that y will also never equal 0. Interesting. That's kind of like a ACT question in and of itself. So with that being said, that's not really the goal. The goal is to graph this thing. Now you already know it looks like this. But let's act like you don't know that. So after you've done 10,000 of them, so you've only done one, you're going to go, you know what? It's something like this. So I'm going to pick an x value way over here, -4. And maybe I'll pick an x value over here, -1, and then a 1, and then a +4. Now somebody could have picked, 2 and 6, -3, -9. You're going to get a very accurate drawing, but I'm going to pick these. So my x values, I'm going to go -4, -1. I'm going to put the 0 in, talk about that, and then 1 and a 4. Again, you don't need to use these exact numbers. But if I plug -4 in for x here, 1 over -4 is just -1/4. If I plug -1 in for x, I get 1 over -1, which is -1. Again, 0 can't happen. You can't have 0 in your denominator. So if I plug a 1 in, 1 over 1 is 1. Put a 4 in, 1 over 4 is 1/4. Now let's take a look at this graph. Let's act like we don't know what it looks like. So let's plot some points. -4, -1, 4. 1, 2, 3, 4. Down a tiny, tiny bit. -1, -1, -1, -1, is right about there. You're like, oh, I can kind of see where this is going. And then we plot these like 1, 1, and then 4, 1, 4, 2, 3, 4, barely up. So you're like, oh, okay, it's getting close to the x-axis, but it doesn't touch it. So you're like, well, that doesn't look like this. So if you get into that little pickle, then we should pick something barely over here to figure out, all right, let's let x be negative 0.01. Figure out what y corresponds to it. Where does it end up? So if we plug that in, we're going to get 1 over negative 0.01. Now you can put that in your calculator if you want. That's going to be negative 100 for my y value. So as you can see, it's over a tiny bit, but then it goes screaming way down. So the rest of my graph is going to go like that. But it never crosses the y-axis. Okay, we're going to talk about that in a minute. And then we're like, well, what happens over here? Well, I'm going to pick something barely over here. I'll stick with the program 0.01. It's barely to the right of the y-axis. So I'm letting x be 0.01. If I plug that in, well, it's going to be the same thing, just positive. So that's going to go screaming up, and then there we have it. Now, some of you guys, when you're graphing this by hand, you might accidentally touch those. Technically, it's wrong, but I'm just looking for effort. These graphs do not touch the x-axis. They don't touch the y-axis. We're going to talk about this more in the next example, but this is called an asymptote. It's something a graph is trying to get really close to but can't touch it. And the same thing goes here. It's trying to touch the x-axis, and it's trying to touch the y-axis. So these are called our asymptotes. Get used to that phrase. It's going to come at you quite a bit. All right, this is it for the pre-lesson. A little different version here. I don't know if you can see this example over here, but I'll make sense of it. Let's start here. It says graph this crazy thing. Now notice it's like 1 over x. So I know my parent function is this. Now this is only the second one you've seen, but hopefully you're like, I know that looks like this because we just did them. Doesn't need to be perfect. And then it goes like this. It just does. Clearly mine's not perfect. That's the parent function. Now remember what I've been saying. Your rules are your rules are your rules for graphing transformations. So x minus 3, that's going to move it right 3. And that's going to move it up 2. So it's like the origin gets moved right 3, 1, 2, 3, up 2, 1, 2. Now in these crazy problems, I like to make a brand new y-axis and a brand new x-axis. So it's kind of like you don't know if you've ever used a scope and a gun just to shoot. It's like the crosshairs just got moved, 3 right, 2 up. So same picture though. So I'm going to draw the same picture on this dotted graph. So this portion would just go right here. This portion would go right here. And now to avoid all the confusion, I'm going to hit pause. Okay, so as you can see, I erased the parent function because it's just too distracting, because they're going to ask us questions now. Now the reason I got this little arrow up here about asymptotes is you see this is an asymptote. That's a horizontal line. So we know by our review, if it's a vertical line, it's going to be x equals whatever it is, -2. You guys can't see it, but this is a horizontal line, and that's y equals 3. So, yes, this has asymptotes. Uh-oh. Phone call. Okay, my phone is ringing off the hook because my son's trying to buy a used car. So I'm trying to do this and deal with a used car dealership, my wife, my son, so forgive me. But here's the phone going crazy. I'm going to ignore it for a second. So asymptotes are right here and right here. So this guy right here is a horizontal line, which matches our y equals. So that'd be y equals, and it crosses y-axis at 2. That's the asymptote. This one is a vertical line, so we know it's x equals, we think 1, 2, 3. That's the other asymptote. Now the domain and range are different stories. Domain is, remember, how far left does it go and how far right does it go? But we got two chunks. So we have to explain this chunk. So the domain would be, goes from negative infinity all the way up to the asymptote, which is 3, but it doesn't touch it. So you got to use parentheses. And starts out again at 3, but it doesn't touch it, and it goes to the right forever. Now we got to think up and down about the range. So how low does this thing go? Well, it goes down forever. So it starts negative infinity. It goes all the way up to the ceiling, which is 2, but it doesn't touch it because it's an asymptote. And then it starts again at 2, doesn't touch it. That's why the parentheses are there. And then it goes up forever and ever and ever. Amen. All right, there's your pre-lesson. Now I can get after this used car.